Now, today we want to do a problem on optimization. It's a fairly typical question. We need to find the size of this tank that will give a total surface area of the metal making up the tank to be a minimum. Now, there's no top on the tank either. The diagram on the right gives an idea of what we've got, and notice that we've labelled the base x by x, because it's square, and h is the height. First step, look at what you're trying to minimize. And the quantity here is the surface area. So let's start writing an equation for that. So A, the area, is equal to, there's four sides, so there's 4 lots of x times h, plus there's a base, which is x squared. We notice that equation has got two variables, x and also h. So we need to eliminate one of these variables. To do that, we need another equation. So the second equation we use is the volume. We're given the volume, 13.5 cubic meters. So if we write an equation for the volume, we could say that the volume of this box is going to be x squared times h, and that's equal to 13.5. If we rewrite that as h equals 13.5 divided by x squared. I've made h the subject. It seems to be somewhat easier in this case. Next step, go back to the original formula, which is the area equals 4 times, no, we've got x, now h is actually 13.5 over x squared, so write that in, plus x squared. Now what we do next is we actually write down the equation in a simplified form. So let's just see, so A is equal to, if we work that out, 4 times 13.5 is equal to 54 over x, and also we have plus x squared still, or we could write that as equal to, let's see, so it's going to be 54 x to the negative 1 plus x squared. Next step is to differentiate, because we want to actually minimize the area, so dA dx is equal to negative 54 x to the minus 2 plus 2x. We know that we make this equal to 0, so therefore if we make that equal to 0, let's just put that at the end here, equals 0, we find in fact that we're going to get something like negative 54 over x squared plus 2x equals 0. Now to make that a bit easier, I'm going to multiply every term by x squared. So I get negative 54, and if I multiply by x squared, that's all we get for the first term, plus 2x cubed, that's multiplying by x squared, equals 0. 0 times any number, or anything gives 0. Making x cubed the subject, 2x cubed would equal 54, which means that x cubed is equal to 3. Whoops, no, x cubed is equal to, redo that, x cubed is equal to 27, I'm jumping steps, and so x is equal to the cube root of 27, x equals 3. That tells me that the x number I've fan for the base is 3 meters. I also need to find the height, so going back to my other equation, I know that h is equal to 13.5 divided by x squared, which is 9, and that's actually 1.5. So finally, let's have a look. What are we trying to actually find for the answer? The question says find the dimensions. So the dimensions are the base, which is x by x, is 3 meters by 3 meters, and the height is equal to 1.5 meters. If we were asked to find the volume, or the area, that should be the area in this case, we would need to calculate the area using one of the formulas that we've got for the area and substitute in those numbers. X equals 3 and the height is 1.5. So that's a method for doing the optimization type questions. Notice the key was finding the quantity to actually optimize first, then differentiate it, put it equal to 0. To do that, we often have to find another equation, because you can only differentiate if you have one variable. Finally, when you've solved the equation equals 0, you need to actually answer the question that was posed in the first place. Hopefully that will be of help to you.